All right, we're going to be covering the upper boundary theorem. All right, we are on Chapter 4, Section 5, dealing with locating zeros of a polynomial function. I want you guys to understand what an upper boundary is. An upper boundary is dealing with the boundary that's over here on the right side. This is the upper boundary of the graph where you would try to find the roots. In this particular case, we don't have roots, we have one root. All right, and this side right here is going to represent the lower boundary. But if you didn't have a graphing calculator and you wanted to find where the roots would be located, we only have one right here between a what? Between a 2 and a 1, okay? How could we find that without having to use the graphing calculator? Because sometimes tests you're going to have to take them, you don't have calculators to see what the graph looks like, okay? Oh, well, that'd be using the calculator. We didn't use the calculator. So what I want you guys to do is in your journal, we're going to do synthetic division here. So in your journal right now, I'd like you guys to set up your problem for some synthetic division. Okay? We're going to write a 2, a -1, a 1, and a -6. Now, just from looking at the graphing calculator, you can kind of see that the upper boundary is where? At a 2. Okay? So, if we wanted to test that, what you would do is you're going to plug in the number 2 right here. Understand, 2 is definitely one of the possible factors. If you do plus or minus p over q, the factors of p over the factors of q, 2 is one of the possible roots. It's not a root, but it's a possible root. So we're going to use synthetic division, and I want you guys to see a pattern. Bringing down the 2. 2 times 2 is 4. Add them together, you get a 3. 2 times 3 is 6. Add these together, get a 7. 2 times 7 is 14, and you get an 8. Now, understand, all these numbers right here, were there any sign changes whatsoever? There are no sign changes. Okay? So being that there's no sign changes, that lets you know that you have an upper boundary. Now, if I use a 3 right here, Noah, if I used a 3, there would also be no sign changes. So if I plugged in a 3 into the same exact process, add those together, 3 times 16 is 48, 48 minus 6 is a 42. Notice there's also no sign changes as well, but which number was less? What did we have over here the first time? What did you guys have? You had an 8. So even though technically 3 could be an upper boundary, the number 2 is a better answer because over here is a smaller number and there's still no sign changes. Okay? So if I go back to what we had before, this is what we had before. Notice, 8 is a lot less than a 42. Okay, so this is a better answer. So your upper boundary, everybody, your upper boundary is equal to 2. Now, how do you know if you have a sign change? Let me show you where that sign change would happen. I'm going to do the exact same problem. In your journal, we're going to type in x to the third, x squared, x to the first, and x to the 0. Okay, these exact same numbers. I'm going to show you where you have a sign change where you know that this is not the upper boundary. Alright, we're going to do synthetic division and we're going to see what happens. Bring down the 2, multiply these together, you get 2. Add them together, you get a 1. Multiply these together, you get a 1. Add them together, you get a 2. Multiply them together, you get a 2, and then you get a -4. From here to here, what do we have? We have a sign change. When you're doing synthetic division and you get a sign change, that lets you know that is not the upper boundary. The the upper boundary, right here, all these numbers have to be either positive or all these numbers have to be negative. Okay? And why did we not choose the number 3 over the number 2? Because when we worked it out, this number was closer to what? This number was closer to the number 0. Okay? So, first thing you got to check, do you have a sign change? Here, we don't, and this number is relatively what? Relatively close to 0. So we're good. Okay? Over here, we can't use the number 1 because even though we're going really, 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 really well, at the very, very, very end, you have a sign change, so that's not going to be your upper boundary. Okay? Now we're going to show you how to find the lower boundary. All right. Caitlin, this time we're going to find the lower boundary.
Yes, we are.
All right. So here's what I need you guys to do. Before we find the lower boundary, what I need you guys to do in your journal, please. All right. To find the lower boundary, the first thing you have to do in your equation is you have to plug in a negative x wherever you see an x. Now, if you're listening to this video and you're wondering why my voice has suddenly become a higher pitched voice, it's probably because a particular student didn't have a pencil. I'm not gonna call you out on YouTube though. Okay. All right. So plug in the dadgum negative x into your polynomial function. Have a little fun doing a function. Come on, man. That's right. It's called a function. Alright, so here we go. How many negatives do we have right here, Caitlin? Don't say, that's right, 3. So we're going to be left with a negative 2x to the power of 3, also known as cube. I was thought you were going to say 1. I was sorely mistaken. I'm glad you said 3.
I'm smart.
Yes, you are. Now, okay, smarty pants. What about this one right here? How many negatives am I circling right here?
3.
3 is right. Good job helping her out, everybody. All right. 1, 2, 3. I have 3. So that's going to be a negative x squared. Ooh, how many do we have here? 1. Very good. Way to go, Miss Smarty Pants. And then we have a negative 6. That's right. So what we're going to do now is we're going to do some synthetic divisions. We have x cubed, x squared, x to the first, x to the 0. What number am I going to put directly underneath x cubed, Adam? Negative 2. How about here? Negative 1 here. Negative 1 here. Negative 6. Good. Now, I want you guys to understand, since I've plugged in a negative 1, all right? If I choose to use a negative 1, I'm actually testing the number positive 1. So if in the synthetic division, if you use a number, always know that you're actually testing the opposite of that number. How do you know it's the opposite? Because how did we start this problem out? We started by plugging in a what? A negative x. So what am I testing? I'm actually not testing a negative 1. I'm actually testing a 1. All right? So here we go. We're going to check this out. Mandy, tell me what to do. I'm bringing down the negative 2. What am I going to do with those numbers right there? Good. Multiply them together. I get a 2. What do I get here? 2 and a minus 1 is a 1. Stop. Right now, I'm testing the lower boundary. What has happened? I've had a what? I've had a sign change. So I'm not going to use it. Once you have a sign change, you can do what? You can stop and realize that's not going to be my lower boundary.
Be inspired to stop.
Sorry? Be inspired to stop. Yes, I have a shirt that has inspired with the symbol of
Hi.
right. See? N. Oh, by the way, I'll write it for people, right? It says N. And it has the pi symbol, right? Okay? And then add on it. Alright? There you go. So right here, this represents what? PI.
That is a cool shirt.
Thank you. The math department all got the same shirt to inspire others to know. All right.
I thought it was some weird word too that is pop, and I didn't understand it so much. Oh God.
No, it's just Mr. Mood. All right. So, by the way, instead of testing testing the number 1, like I thought we tested the number -1. Actually, we tested the number 1 because it's always the opposite of what you plug in. So now I'm going to test the number 0. The cool thing about the number 0 is I don't have to worry about being the opposite of 0. Neither positive
You're
nor
just
negative.
gonna get 0 for every number.
No, well, kind of. All right, so we're going to bring down a -2, multiply it, get 0. Bring down a -1, multiply it.
Oh, I forgot about that.
Bring down the -1, multiply it. Bring down the -6. Do we have any sign changes whatsoever?
No.
No sign changes. What have we just found?
Remainder.
Lower bound.
The lower boundary is correct. We just found the lower boundary, and the lower boundary is the number 0. Which means this, everybody. Which means all of my roots. So for the answer for number 14, I'm going to put lower, I'm going to put upper. The lower boundary is 0 and the upper boundary is 2, and all of my roots can be located between those two numbers. Okay? This is how to figure out where your roots are located in a problem if you don't have a graphing calculator accessible to you. All right?